you. And welcome to the 2CC session. And this time around, we will be continuing where we left off from last week, wherein we tried to create the core mechanics of the for our racing game, which the AI will be interfacing upon. So, a major factor about what happened last week was that a lot of the core mechanics, they didn't exactly work out properly, so we will try fixing them and try creating the base of the AI. Okay, so I'll start the screen. So uh, last session I already taught how to install Unity and how to install Unity Hub, how to install the Unity editor from the hub, and then managing the project from the hub. So you just so I'll click on the player to CPU ready, which is the project that was created just for this event. So while the Unity is loading, what I'll tell you is that the main part about the core mechanics was that there were so many small things that were going wrong that I basically had to overhaul the entire thing. Uh, so I will show the. I will be making all the changes for you live here, and here we left off. We had a ground and a car. Okay, and the car has two components for simulating the car itself and the inputs, and simulating the individual wheels. So we are going to simplify our model and simplify the model physics. And the first thing we need to do is open the project folder in Visual Studio, from where we can edit our code. Right now Visual Studio is loading. Just hang with me here. It will take at most half a minute. Okay, so basically I'll be overhauling the whole system, and then I will add the AI and the AI car, and creating a base for the AI itself. Okay, so here we are at Visual Studio, and the first thing I'm going to do is change up all the things that were basically going wrong. So to simplify the model, I am not going to have any of the wheel spin, loss of grip, and all that kind of stuff. It will be the model will be as simple as possible. For steering, we got the steering angle. If the if that wheel will be steering the car, and we're going to have another float steering radius, which is basically to which radius the car will be turning. Then and then in the miscellaneous, it will be stuff that will be useful for useful for actually moving the car the way we want it to. So hit distance it was basically made for debugging purposes, and it has no major use, but for debugging purposes I am going to make two new variables public. I'll call it traction force and turning force. I think and as the name suggests, traction force will be for the straight line physics, and turning force will be towards turning to the left or to the right. And the parent rigid body reference, and then moving on to the functions that will be changed. So we're going to check for grounded, and alright, we did not update any of the wheel RPM. That caused several issues. That was a root cause of several of the issues that were encountered previously. So we're going to change that so that it works. So if it is grounded, RPM will be speed by 2 pi r. So mathf dot pi into radius, and then we'll be applying the acceleration and steering functions. The grounded check is fine. We wouldn't need to change that. And okay, acceleration function. So we are not making use of the for of like loss of grip and loss of traction phenomena, for example understeer, oversteer, etc. But so we can simply remove it. Then okay, then we will be changing how the force is applied. Just a second, I need now changing how the force is applied. We're going to calculate the traction force that will be applied onto the parent's rigid body, and it will be transformed dot forward into acceleration force, because that is a force like it's already given by the car simulation, and we don't need to log it and change this to just add force and traction force. So we simplified our acceleration model. That will allow us to that will let us do all this stuff. That will let the car move in a straight line. Then applying the steering input. So for this we are going to, it's kind of like de-simplifying it but also simplifying it. It will make sense as I make the code. So this is local rotation equal to Euler 0, steering angle and 0. This transform.local rotation, it will be done mostly for just the visuals that will be happening, and after this the car won't be able to turn if the wheel is off the ground. So if our wheel is on the ground, if our wheel is not on the ground, we'll just skip, and turning force equal to transform dot right into parent RB wait OI into parent RB dot mass speed radius by 2, because that's how I found out, like you need to reduce how much force you are putting onto this, like by a lot. Then it's very low. Okay, I'll just update that. Now I think the sound levels should be fine, and yeah, okay, now it should be good. Then changing the turning force. Okay, instead of I'll do 8. Okay, because it actually gets like super tight for how it is. No, oh wait, no, it should be multiple. Okay, then we just add force at position, turning force. Oh, no, oh, turning force. And then it is parent or b. No. Yeah, dot transform dot position plus dot transform dot forward into transform dot local position dot z. Okay, this is a very long expression, but it's but what it is doing is fairly understandable and fairly simple. So you take the parent's global position that is there, the world space position of the transform, and you add to it the parent transform forward times parent local position z. So so this is the transform local position z. It will be it will show this if you have this object, and I'll just no why okay. So if you have this object here, and here is the origin of the local here's the origin of the parent, then the local position would be this this much gap that's here. But if the car is rotated slightly, like 90, z is here, but if you directly add it, it will add in the world space coordinate, so it will apply the force here. So that is not good. So instead what we do, we multiply that distance by the direction it is, so that you can have a proper way of finding out where the front axle is, and from there we are going to apply our forces, apply our turning force more specifically. Now continuing with our changes, steering is this way. Okay, so we're basically done with the wheel simulation. Then we change the car simulation. Now here is where we have a lot of changes set up for this. The first thing, I'm just going to rename this to torque, because it's more intuitive way of recognizing how much forces are being produced. So, torque. And throttle ratio I can remove for simplifying the model a little bit. And then oh right, drag is super important here, so I just add a float here, call it drag coefficient, and I'll give it a range of 0 to 5. Then we are done with this. Transmission stats. Okay, for ratios and current gear, we also need differential and clutch ratios, but I'm just going to combine them into one variable. I'll call it a differential ratio, or diff ratio for short. Oh no more. Okay, yeah, no, again, yeah. Then moving on to the steering. Steering is fine, yeah. And inputs, I am not sure, because you'll see later. And a few miscellaneous things for our debugging purposes. First is how much force how much drag force is being put onto the how much resistance forces are being put onto the onto the car. Okay, this is just for debugging purposes so that we know what's happening, and then we move on to how we are initializing the whole car. So first thing, rigid body, okay, RPM, then wheels, wheel count. I am trying to figure out where is any issue. Powered wheels, yes, this. Okay, one thing, we are going to log the each of these wheels components so that we know that all of them are initialized properly, because this class is completely custom made. You can't exactly keep it in the same view it as a component. That's what I mean. Then powered wheels count, okay, current gear should be okay. This is misplaced. Yeah. Now moving on to update function. I'll be making all of this from scratch, so bear with me. Okay. Now our acceleration input out, get access. I'm not sure about the gear ratios because then we will need to code either extra outputs from the AI or just get rid of it completely to have a single geared engine that goes like super high in the RPMs. We'll figure it out as we go. Our acceleration function, then acceleration input, the steering input, then syncing our RPM. It's a fairly small code. I'll do it directly in the update function itself, even though it is mostly recommended that if you have like a code block that's like larger than 4 lines, maybe you should probably just make use of an external function so that it is easier to manage the update function. So engine RPM syncing, so we'll loop through the wheels, then if is powered, no, okay, wheels is powered, then dot RPM, powered wheels into okay. How did I get the ratios of current gear and differential ratio in the denominator? It will be more apparent once I've done with the acceleration input response, steering input response, the resistive forces in the gear shifting. Okay, we have all the initializations, accelerations. Okay, let's do this. So for our acceleration, oh, it's a void function. No, okay, never mind. Then we will have a per wheel force that will be applied if our acceleration input is less than 0, that is if we are braking, then per wheel force should be equal to brake torque. Evaluate on the input, because the brakes are directly dependent on how hard you press the brake pedal and not any other major factors. It's usually a linear curve. So, and yes, then wheels not count because all 4 wheels have brakes. We are just acceleration force per wheel force. Then if our acceleration input is greater than 0, that is if we're accelerating here, our per wheel force will be engine torque dot evaluate engine RPM into ratios current gear diff ratio. So that's where the ratios current gear and diff ratio comes here, because each when the power is being sent to the rear wheels between the engine and the wheels, there sits the differential and your transmission. So the transmission's ratio they multiply, and then the differential ratio also multiplies. So when you are trying to calculate the engine RPM, when the wheels RPM is given, you are going to divide them. Now having the now updating all the wheels. So wheel I wait I less than count plus plus no if no I is powered acceleration force oh right, we need to divide this by the wheel radius and also by the number of powered wheels there are, because the power gets divided for each and every wheel, either it's equal or unequal. It depends on the differential, if it's limited slip diffraction and all that, but we only need for the but we're assuming all the stuff with this. Oh, okay. Oh, right. We're going to have to divide this by the wheel radius later, like when we are actually multiplying, because we need to access the individual wheel. Acceleration force equal to per wheel force divided by the radius. And finally, if it's neither less than 0 nor greater than 0, that is we are basically the foot is off the gas and off the brakes, what we are going to do is basically do the same thing as the engine as the acceleration one, but instead of using the engine torque, we'll use the neutral torque, that like no input is being given. Just a sec. Sound is still lower. Is it better now? I think. No, it is not. Just give me a sec. I need to. No, I can't really change it anymore. Uh, it's already running at max volume. Sorry, Shiv Shankar. Uh, Finally, we will make use of this code only. We'll just Control C, Control V, and change the engine torque into neutral torque. And tada, our acceleration function is done finally. Now our steering input. For steering input, what we're going to do is, if we're not steering, we're going to skip, because otherwise we'll be doing calculations. Otherwise the calculations will be skewed, because the we'll be dividing by 0 basically in his case. So no, it's a big no. Like, we are not going to do that stuff. Then oh yeah, return. So how much is our turning radius here? It will be the square root of the steer radius that is actually there, squared divided by steering input squared. Why did I square and then square root it? It's basically to get a curve that is not linear. Okay, so the linear steering, it's usually quite hard to figure out, especially if the angle is not linear because of the radius being linear. So that's why I chose to have the ratio squared and then square rooted. Okay, if that makes sense, good enough. Otherwise, maybe try just following through it. It's a better way of doing all that stuff. Then the angle that is there, angle and right angle. So why am I still having angles here if my forces are being determined by the radius? That is the question that will come. I will answer that question once I'm done with the steering input. Okay, so our first, we will, if input is less than 0, that is, we are turning to the left. Our left angle will be minus math f dot a tan. A tan is basically calculates tan inverse function, radius minus track width by 2. And right angle will be radius plus track width by 2. Then we have our and then the steering radius we are going to update here itself. Dot front left dot radius minus radius right, also minus radius. Why did I do a minus on all of these? It's because our because of how we use the square root, our radius becomes positive even if we are turning right or left. And afterwards we're done with steering to the left. Now we'll manage steering to the right. Now the right hand steering, okay, so for right hand steering I'll take this code because there's only minor alterations. That's how usually game dev works. You control C, control V your own code several times by making small alterations on the way. Okay. So radius here is positive, and the left angle and right angles, they will be swapped, and we will keep them positive. Positive angle will be a clockwise movement when viewed from the top. So in the negative angle, the wheel will turn to the left. Oh, sorry. And on the positive angle, the wheel will turn to the right. So this is our function basically. Then okay, and then finally we update our steer angles of the individual of the wheels. Front left steer angle is left angle into 180 by pi. Why did I do a 180 by pi? It's because the steering angle was calculated in radians here. That's why. And it should be a right angle, and that's our steering input handled. So I'll save it and see how I'll need to change all this. Okay, most of the values are now 0. Shift it. Oh my goodness. Okay. Yeah. Shift it to perspective mode. Max RPM right now 10k. We might change it because I'm not sure about the gears. Then we have our engine torque neutral torque. Okay, we will have to define them on our own. And what about this? Wheel radius steers the car. Speed is ground. Okay, that's all. Okay, and this. Okay. So we're making a torque. Oh my. Okay, holy lag. Okay. So I'll zoom it normally until I get to, I guess, 200, 300. Okay. And then after that I'll move it like this and do a control scroll so that I can zoom out just horizontally. I need to get all the way to 10k. Yep. I'll just take this curve and modify it. This peak is too high. I'll edit this. So max torque, I'll say 6800 rpm, and it will be 350 is okay only. I just need to shift it. Edit this. At basically super low RPMs, we are going to have 100. No, 100 is too low. Edit, change it to 250. No, 200. Yep. And we just bada bing. Bada boom. Where is 10 to 8 so I'll just keep it as close to here as possible. There's a sharp drop off so that when you are at the peak RPM, you are going to experience the an extreme drop in power that will let the drag force take over and push your RPM back to the max. So it will give you that same toot 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 sound when the red line is reached. Then I'll just did I change something? Control Z. Yeah, okay, right. Then we are going to I'll just remove this preset and add this as a new preset because I'll be using this but modified slightly for my other materials. For example, here, so I'll zoom out so that I can at least see it. And here is our peak. Control scroll for horizontal. Shift a little bit so that you can see. So what I'll do is select everything with Control A. I'll make it shorter a little bit so that there's some difference, and then I'll shift it down. Here it's a bit extreme, but it's what happens. It's basically engine braking. Like you let go of the gas and the car basically decelerates from the engine as well as the drag force. So we're done with this. Then the brake torque, I already have a prefab, I think. Oh, it's the standard sigmoid. I'll just zoom out so that I can see a -1. Yeah, -1. Control A. Shift it. Okay. Make it a little bit bigger. Edit this key. No. Okay. Then I'll change this key to be a 0. 0, 0. Now the brake force, our minimum, the most the output can go is a -1, and I think we should keep the brake torque at 200. Now I'll do a shift scroll to zoom onto the vertical axis. I'll add another key that will skew this. I'll add another key so that I have some change. I think it should be a -0.2, 0, and okay. So this will be our curve. Instead of 0.2, I'll put it to a okay, 0.1. Yeah, that's better. Now this is our braking curve. I'll save it. This used to be my new. this used to be my previous curve. Now this is my new. I'll delete the old one. Oh wait, I think it was some other graph that was super important. Oh, it was a grip slip one. Okay, it's fine then. Now that we're done with all this, we'll put up a drag coefficient. I'll call it 2. It is very low, but deal with it. It's a little box here. Then for the gear ratios, let's say I'll keep the differential at 5. 0 is our reverse gear here. Then our reverse gear will be minus 2.9. Neutral should be 0 because you are not doing anything. Then we have this. Oh right, and also in the wheel sim, if our speed is less than point 0.1, we are going to return, because at that point I think the car is mostly stopped, and a stopped car shouldn't exactly be turning around when you are moving the steering wheel. So, I saw it happen once when I was testing it, but it happens. Okay, then we have all this. Then we change our values to save the scene once, just in case. So our first 2.7, second gear is 2.4. Wait, it should be a 3.8. 1.4, 1.4, 1.7. Okay. Then differential ratio is 5. Wheelbase. The wheelbase 2.6. Front is 1.3. Rear is minus 1. Yeah, 2.6. And our track width 0.9, 0.9. Yep. And then steering radius, I'm going to call it 20. Now most of our values are done. Let's test it. Our console, what has to say? Yep, it's a wheel sim, wheel sim, wheel sim, wheel sim. It is properly initialized. I'm pressing A and the steering input is going nuts. We need to configure the input manager. Where are you, manager? I need to speak to you. Oh wait, not preferences. Okay, input manager, then steering. Okay. I'm going to remove the A, D buttons. Okay. I don't care if you steer with WASD. Okay. This is for my comfort, because AZ I use for acceleration, S and X for changing the gears, and left and right for changing my direction. I mean, you can change it to whichever way you want. Handbrake, it is not really needed now because we've simplified the driving model. And okay, now how is the inputs? Yep, inputs are working proper. I changed the gear. Should be throwing errors though. No. Okay. It's not letting me change gears. What could have gone wrong? Here's the code. Okay, I am stupid. Okay, I have done a very big mistake. Technical Vishnu, my laptop has 8 gigs of RAM only. I'll make another function for gear shifting. Okay, And also I forgot to call all of these functions. Just uh, just bear with me here, okay? And okay, yeah, gear shifter. mm, if R, if we pressed no string gear up and our current gear less than ratio so length minus 1. mm, What was the time now? It's 11:45. Okay. Uh, and else if you usually shouldn't put an else when you are getting doing the get button functions, because then it won't recognize two buttons is being pressed at the same time. But here we want that. We want to have only one button pressed at once, just for this case, because you can't really shift up and down at the same time. Gear down and okay, and then I call all of these function. Steering input response, and then I have the gear shifting function. Okay, let's do this. The whole week's work has gone. Okay, now it's giving me force assign attempt for car is not valid. Input force is this. Okay, drag force is nothing. Okay, it will just keep. Okay, that's new. That is not supposed to happen. Does it happen every? Okay. Okay, this is fine. This is fine. This is fine. So I'll edit this at minus. Wait. For a 0, we have a 0. And I add another key. For a 5, we also have a 0. Clamped auto. Clamped. Okay. Now we are good. Edit. No, not this one. Zoom in. This one. Change it to 500. Yes, that is it. Okay, just don't mind me. There, it happens sometimes. Then okay, shift up. That's a relief. We pressed. That is not supposed to happen. Okay, that is not supposed to happen. Where's this function? Oh, right. Okay. Another small mistake. Not delta time. We forgot this. This is super important, especially when you are working with update functions, because every time the update function is called, it's once per frame, and the time in between the frames is not fixed. Okay, it happens sometimes, just sometimes due to lag, and sometimes due to just due to just not enough resources being there, and so the frame rate is being inconsistent. It happens. Now we should have a better a better driving experience. Okay, let's go. Okay, that's a start. That is a start. Let's shift it to 1. See what happens. Because I think it's the acceleration force that's going ham. Oh, okay. Now it is not behaving. Oh, okay, not enough force. Okay, the attendance link has been sent to the chat. Just make sure you give your attendance. And resistive, we did not even apply the resistance forces, and also this force is too tiny. So okay, back to the coding. Back to the coding it is then. Okay, void apply resistance forces. So our drag, the first forces are drag minus drag. Oh wait, no, it's not supposed to be here. It's supposed to be here. So our drag force is minus drag coefficient into, wait, we did, oh, okay, continue, moving on, minus again drag coefficient, then rb dot velocity into rb dot velocity dot magnitude. Then we have the rolling resistance equal to is 30 times drag coefficient into rb dot velocity. This is not supposed to be here. Okay, it's a misplaced shift character. Then we add this force also after multiplying by delta time. Super important step, never forget, especially because we are working with update function here. Okay. Drag force plus rolling resistance, and we're going to do this function before our input responses. Okay, after we're done with all this, we will have to see if it works. Then we have our, okay, now attempt number 3. Let's go. says drag force 0. Okay, I'll try again to see. Is there a wheel even turning? Yes, it is. It's not that much. Huh. Okay. Maybe we do not need to. Where is the wheel sim? Maybe we do not need that by 8. Now, what does it have to say? Also, let's do it. Step number 3. Here the RPM is being. Turning is slow. Gee, I wonder why. If I decrease this to 15, and I need to. Okay. So second time charm. What, turning from this? No. Okay. Left. Where are we turning? Very, very slowly. It's not supposed to be like this. Just give me a moment. I will be right back. Yeah, now I have returned. So I think it's mostly the turning mostly got to do with how we are assigning all the stuff. Okay, so our radius is, I think it is supposed to be fine only. This is a good this is good turning out here. Okay, we actually have some turning. Okay, it's hard to see which direction we're facing. So what I'm going to do for now is create a small texture file that will be used by this used by the game. Okay, so our scale is 30 by 30. It will be tiled 60 by 60. Okay, so I'll open up paint. Oh wait, not this. Then we have, okay, we're in paint. We will resize it. Pixels, no, since it is like mostly, my goodness, there's like, okay, there's no way I can disable the dark mode on the enable dark mode, and so it's too bright for me, at least right now. I'll make a grid. I'll make a grid that will help us orient ourselves, help us see where we're going. 8 pixels, I think. Okay, I'm going to save it, and there's my project. There are 2 assets. Then I'll make a new folder and I'll call it textures, and I'll rename this to ground texture. I think I should let's see how it looks in the engine itself. Assets, textures, ground texture. Okay, now you see that you zoom in, it is blurry. There's not much you can do about this, but what you can do, because like at this big of a scale, even a 4K texture, 4096 by 4096, which requires so much VRAM, you're going to kill your GPU, that if you use it too much. So and still it would look blurry. So what we'll do, we'll just tile this. We'll tile it 60 times and 60 times. So now we have a point of reference, but I don't know, something feels off about this. Is it just me, or does it actually feel a little bit off? So what I'll do is that wait, where's the grid lines? Super important here. So it's a 4 4. Oh, okay. I'm going to need a line that's 1 pixel. Just go across this here, and here as well. Okay. Okay. So this is here. Then I'll have a black, which will be the border. Okay, then 3 pixel. Okay, that works. No, I use 1 pixel only. So what I'll do is no, wrong color. Okay, now the scroll wheel had to work. Okay. And oh, now that this is here, I will I'll use this. No, this should be the other way around, I think. No, this is better. Save it. Let it. Okay. We need more tiling for this. It is 75 by 75. Now if I play, I can. Okay. Okay, the torque calculation. The torque calculation is a bit off, and at reverse speed it is okay. What if I interpolate? Okay, it works somewhat. Okay, it's okay. It is still oversteery. Wait, how high did the RPM range go? Because okay, the RPM doesn't go that high. This is fine. This is fine. What about the drag force? At least the drag. Okay. Drag force isn't doing anything. I can't put apply resistance forces. Okay, this is getting out of hand, but I think this will have to do for now because we can't Getting this right is actually quite difficult. RV dot velocity, velocity dot magnitude, this time to delta what about the drag coefficient? Is that okay? That value is okay. This value was the main culprit. Okay, now we can see if it works. Come on, drag force, help. Please. Okay, but the torque is still off. Wait, what if I... Is it because of the... No, okay. Oh, this is actually getting quite stressful. So here, and then this. Okay. So add for the position. This is this is not good. This is not good. This is not supposed to happen like this. But we are running short of time here because I need to end this. Oh wait. We have time. Never mind. Situation misread. Let's continue. Something feels off about this. Do it 16. Now it is supposed to put the torque somewhere. Huh. This input is lagging. It's not supposed to lag this hard. What if I change it to fixed update? Oh, not foxed. Fixed update. So instead of updating every frame, we're updating every physics time step. Okay, please do something. Bro, this lag feels something out of like Minecraft when the server is like trying to handle too much stuff. Left angle. Wait, I was only saying to the right, no? What about left? Okay, yeah, they are handled the same way. It's lagged a little bit. And why is the engine RPM so low even at higher speeds? Like, I think we can get by with single geared operations for now. The bigger problem is with the turning. I don't know, man. It's not supposed to be like this. Thank you, Atar. It was actually completely by accident. Okay. I'm trying to figure out what is going wrong here because it's not supposed to be like this. I think I will. I'll change it to. I'll just keep it at this only. We'll let the AI drift around if it wants. Okay. So after this, we are working with the AI. So let me explain with how the AI will work. Oh god, why did I close paint? I'm going to need to explain all that stuff and resize it. The pixels 512. No, okay, okay. Uh, okay, resize pixels. I need it. I think 1280 by 720. I mean, just uh, I think there should be a dark mode with MS Paint because it is it's literally a flashbang at this point. Okay, pencil tool and removing the grid lines. Okay. So, oh my goodness, okay, lag. Yeah. So how it will work is, here's our car. Okay, don't mind the drawing. I'm drawing with a mouse here. So this is the car's origin. It's going to see in 8 different directions. How are we going to help it see is that it's basically the same method that we used for having the used for calculating whether the wheels are on the ground or not. Okay, so we will cast 8 rays in these directions, and then when you find and if you hit anything, for example the walls of a track, then you are going to get a warning, not a warning, you're going to get an information on a raycast hit. Okay, so that is what we are going to be using. So we will have 8 uh, of these distances that will be fed into the AI. 3 4 5 6 7 8, and I think we should just keep it at 2 outputs so that it's like easier for the AI. And since we're doing all of it in like a single gear, we will not really need to do gear shifts. Oh, speaking of gear shifts, I think then we can ignore this one as well. To delete array element and delete array element, because let's see what happens at this moment. Array index outside of bounds. Okay, I can roll with that. We just change it to 0 and ta-da. Come on. Rigid body for okay, that now it's okay. And yeah, why is the torque not applying properly? That's my biggest concern here. I guess I will have to change it, like change the angle manually and let the straight line physics work out the whole thing. And have the straight line physics basically grip the car into going straight. So basically we'll be drifting all the way. I think that is exactly what we will have to do with the physics. What that okay, then that means most of our code on the wheel sims of the oh wait, not most of it. Okay, I did not turn the wheels visually as well. I am very sorry because it happens sometimes. Oh no! Oh no 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 no. Okay, okay, okay. That's why it was not happening anything. Okay, I am uh, transform dot local. No wait, I did change it. Wait, what? What? I did change it. Okay, right. Okay, so this is the thing. Then we will have to calculate it. Looks like I'll have to pause the stream again to do it. Okay, and just for notice, like I'll end this stream at 1:30. So we have only 1 hour remaining on this 2.5 hour long session. So I'll just comment it. No, not shift. Wait. No. No. Wait. What was the shortcut key for this? Okay. Okay. That also works. Okay. So people who did not. So for the people who did not notice, the shortcut key I used to comment this is where I selected the whole thing by shift home, and then I pressed control shift and /. It will comment out the line. Okay, I don't know, it was working a few minutes ago, like just the control, and then I don't know, man, this is sometimes has a mind of its own or something. I'll do this calculation later. Okay, so we'll just have to deal with it for now. So moving on to having a car, I mean a AI. So in the scripts folder, I'll make another folder. I'll call it AI, where the AI will live, and over there I will have a new item. It will be a mono behavior, and I'll call it AI car sim. Create it, my boy. Create it. Okay. And then we have AI car sim. So what I will be doing here is copying. Shut up. It train. There was a train. Okay. So then we have the. Okay. So what we will be doing is basically this train, man. I'm tired of it. So our wheel set is here. Well, find yourself, man. Ambiguity, wheel set front left, and what ambiguity? What kind of ambiguity, man? What is this? I mean, this thing is fighting me at this point. This is actually trying to annoy me now. So instead, I'll just go to the script folder. I'll add another script. Another component script. I'll call it the wheel set. Like absolutely lack of respect. Okay. Then I'll take this. Control X. Control V. No. Come on, Unity. I mean, you get it. Then we'll shut up, VS Visual Studio. I'm changing it. Car sim, wheel set removed. Okay. Then this is here. Okay. Then I'll change this. Oh wait. Okay. This will allow me to do a small change in the code structure. Is that I don't need to initialize all this. All I'll need to do is wheels equal to get component wheel set, and okay, this is way more this is better. And it's just a reference at this point, so I can move it all the way down to miscellaneous. Thank you, Abhishek. I am deeply honored to have the Chad title given to me. There is no start or update to this. It will be directly leeching off of the pre-existing component, and then oh wait, gear shifting is useless now because we're going the single gear way, and gear shifting gone, and finally after so long a big Control C Control V. No, not pen, not pen. Okay. Then inputs, for now I'll keep it 0 here and 0 here. Save it. We go to Unity, compile it, man. Compile it, just compile yourself. Okay, then I need to add another component. And first clear this. Scripts, car, wheel set, please, thank you. Then front left, front right. Oh, rear left and a rear right, and our wheels count is 4. It is actually taking quite long to make this. It's not supposed to be this long. Now that we're done with this, we have to copy this object, and I'll copy it, then I rename this to player car. Oh right. Oh, copy, paste, rename to AI car. AI car will not have this component. Instead, AI car will have this component. Okay, then I need to copy these values. Copy. I need to paste. No, I don't want to make all of this from scratch. Okay, for this I am going to remove all of the presets that I made custom. The first one is for the engine torque. The second one is for the neutral torque, and the third one is for the braking torque. Then okay, then we will have our AI car. Please accept my stuff. Okay, and last one is our braking. We're done with this, and we will have our ratios. We need 1, should be I think 2, 3.8. Diff ratio was 2. Yep, what, 2.6, 1.8, 15. The rest is okay. This drag coef should be 2. The red line is 10,284. Did I accidentally close the stream or something? No. Okay. 10,284. We're done with this. Then the okay, at least the wheel values are coming. Then the body. We're going to need another material so that we can differentiate between them. Albedo, I can change it. Okay, right. Materials. I'm making a new material. Yes. Where's ground? Not as a Unity. What is this? Oh, Unity, you wonder why we hate you so much. Okay. Right. Okay. Then, right. We are creating a new material. AI car body material. The name is long. Deal with it. Albedo. I'll change it to red because it is standard color for the opponent. Not red, a little bit darker I think. Yeah, that's nice. Then what? Highly metallic and very smooth. And that's it. And AI car, please accept my component. No, body, please accept. Yes. And just so that you can identify where it is, I'm going to put it a little bit to the left. Remember, negative x means left, positive x means right, positive z means forward, negative z means backward. Then after this we have to change it. We need to add machine learning. Okay, let the fun begin. So how we are going to work it is that we will have we will have another script that will have our machine learning model in it. Okay, and also reward gates. Oh goodness me. Okay, so I'll add another script. I'll call it neural network behavior. Okay, that was fast. Okay, so we will be making use of a normal neural network, and we will need reward gates. Okay, so I'll create a header. We'll call it AI components, and the first thing will be the distances, and these distances will be our input. Hidden layer 1, public, 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 float outputs, not flout. Come on, right? I do have a broken right arrow key. If any of the on-campus friends and mates will can confirm this, okay? Unreal Engine 4, yes, maybe we will. Okay, just wait for it then. Finally, we will have our weights. Oh goodness me. Header AI node weights, public float dists, no, not what is, okay, dists to hidden 1, hidden 1 to outputs. I'll be like right back. I need to go to the washroom real fast. Okay, I have returned. Now we have our hidden two outputs, and we'll need a function for having the thing. Not random? No. Wait, what was the library for random? Was it Unity engine dot random? Engine dot. No. Weird. Wait, is random? Okay, you have to be joking me. Header miscellaneous random RNG. Thank you. So after this, cannot declare a variable of static type random, make field a read only. Enter. Okay, now does it have a okay, enter, remove one. No, oh, it's only unused one. Okay, so RNG equal to new random. Huh? Oh, oh, okay, okay, I will be. Oh, come on, you idiot. Miscellaneous AI sim, AI interface. I call it the AI interface, and so the this input Excel input will be defined by the neural network behavior. Okay, so AI interface and variable RNG is a new. Can you have to be joking me, man. You have to be joking. This is not supposed to be like this. What is it? Okay, please. Even okay. So explicit is saying implicit, implicit is saying explicit. Very nice. Okay, so what I will do then? I will need to. This is annoying now. Please just let me. Please, RNG equal to new random. Please. No, not it's It's not letting me. This is not. It's not supposed to happen like this. So what we are forced to do is not use it currently. Okay. And for initializing, what I will do is have. Oh right. Wait. Wait a minute. Okay, I did another mistake. I'm going to need another class, neuron, neuron, yeah. And public neuron what problem. Okay, thank you. Wait. Okay, this is not needed then. Never mind, this is like unnecessary. Okay, distance to hidden to outputs. Also float activation float x return x. For now I will change it. Okay, float return. Okay, so I can change it whenever I want. So return should be what math return. Okay, I can make use of normal activation functions. 1 or 2 minus. I will need to take into reference like one of my older programming codes, and I forgot where I kept it. Okay, just bear with me here because we are going on to a roller coaster ride. The coding stuff. Where is the net neural net? This should do. This okay. Open. Come on, VS Code. Come on, just give me what I want. No. Okay, it's not there. Okay, this is fine. Okay, this is better. Oh my goodness, train is so loud I can't even think properly. Okay, activation, please. Oh, where is my activation? Wait, sigmoid. There it is. 1 minus 2 by 1 plus exponent. Okay. 1 minus 2 by 1 minus exponent. Is that what it is? Yeah. Okay. And then I also need the activation derivative. Float x, and we return this. And yes, I know this is not the neatest method of actually teaching stuff, but sometimes you do need to take your own references. Okay, sometimes taking your own reference is a good thing. 1 plus x, 1 plus x. And that's it. After this, I would probably not need the reference, but the folder is still open in case I need. So this 1 plus x into 1 minus x. uh, then we got all this. In start, I will need to capture the weights, and then to head capture these are the weights, and this interface. Alright, I'll also need a second. Will I need yeah, I will need access to the raycasting and the okay, raycasting. Let's do it then. Nothing left to it but to do it. So this is how it will be. So at the start we're initializing the whole thing. Update. First we will capture distances. Helper functions. And then functions. Okay, so first thing we're going to do is void get distances. In here what we will do is wait, what has happened? Dismiss. I don't need your updates. I already like almost I almost uninstalled Visual Studio because of that update. Okay, so getting the distances, we need 8 raycast states. Hits hit 8. Okay, then for print I equal to 0, I is less than 8, I plus plus new integer, no, not integer, float 8. Hidden equal to new float. I think I should keep 10. And for the final one, outputs new float 2. And then we will be multiplying this. It's like 8. Hidden layer 1 is oh wait, no. Dist to hidden layer 1 is equal to new float. It should be eight, right? 10. Right. Should be 8 by 10, I think. Yeah, 8 by 10. 8 by 10. 10. What? Okay. For int I equal to 0, I is less than 8, I plus plus dist to hidden 1 I is equal to new, not equal to float 10. This should give us our distances to hidden weights. Then we need our hidden to outputs. And also there's only one layer. Oh. Change that, and yeah. We do the same thing for our outputs. So wait, shouldn't be a one here. To outputs, go to new float 10 for int I equal to 0, I is less than 10, I plus plus. No, no. Head into outputs, I is equal to new float 2. I think it should be good. Just allow me to check that once on MS Paint. So if I delete this, move to pencil, 8, then add this. Should be 8 by 10, I think. Then you multiply. Okay, this is getting a little bit complicated. I'll need to make my own multiplication algo as well then. It's doable. Okay. Then we will have our into outputs are initialized, then interface equal to get component. I curse them, not 0 here. Okay. Then we have to basically yeah, getting the distances now, because all of this is initialized properly. Let's see how the AI card sim looks now. I think. Oh my. Okay. And we will need to add this boy to our so many people texting. This is not good. And it's already 1. Crap. Okay, I need to speed up just a little bit. Right, score. I forgot. Score is a very important part of like this kind of unsupervised learning. Float score, and I will need reward gates that will add the score, because you can't exactly I can't be bothered to create a whole subsystem for capturing my inputs on the basis of like where I'm driving, and then just keep all of that as a function of keep all of that as a function, and then let the AI train on that, because it is basically something I'm creating on the fly. So my driving wouldn't be perfect, and it will try to copy my driving instead. So we'll need to create our own scoring function, and this so public game object, I'll call it what should I call it? Yeah, reward gates. Reward gates. Wait, what is does it not show the weights here? No, it does not. Interesting. Very interesting. So this is the thing. And then I need to get the distances. Okay. So we will do a physics dot raycast. Right, I'll need to do a direction for all of. I need to keep a direction for the three raycast directions. That is what I will be doing. Just give me a sec. Okay, I'm back. So how? Okay, we'll need to store the raycast directions as well. So okay, then we need to do the origin. This is supposed to be our not transform dot position. There was this direction. Okay, transform, not transform. No, not no. We don't need the transform. We need raycast directions I. Then our max distance is no, not 5. 5 is too short. We'll just let it keep going. Out hits I. Wait, we don't need multiple hits. And yeah, okay. So out hit, because it is singular now. And dists I equal to hit dot distance. So we will go in the directions and calculate our distance from that. Wait, there should be a there should be an overload for max. Okay, that's what we needed. I'll limit it to 50. One thing to note, this wouldn't actually do anything for now, because all we have is a flat surface that goes on forever. Okay, I could point this all of these down a little bit, but I would rather not. I would rather just keep it going flat and have the race track protrude a little bit upwards from the edge, so that it knows where the where the track edges are. It's a dirty trick, but it's a good trick, so we'll stick with that. Now after all this, we got the distances. Let's just see how it is working, because we would still be able to see the distances being updated if I move my car around. So get dists. Okay. Now, please. Huh. Now it doesn't want to turn. What is this? What has happened? Oh, right. Right. I disconnected all the steering. Never mind. Never mind. And what did I next? Okay. Let's remove this and see. What did I do for the wheel simulation? Check grounded. Okay, I did not keep any minimum distance check. Okay, that also works. It's not doing anything. It's not capturing. What is the layer mask? No. I think it's got something to do with transform, maybe. Okay, we'll get back to it a little bit later because we will need a proper racetrack to actually get it to work. So instead, what I'm going to do is uh, make a training function that will train the AI. But I will also need. Okay. Okay. Void train single. What this will do is it will create a single data sample that will give the AI some feedback. So what we are going to do is the score wait a minute, this is not good. Not good. Okay, this is not good because a lot of the systems that we have, they aren't ready for it, and I don't think I have enough time to create a whole racetrack right here in front of you. So what I am going to do now is finish the session right here, and I shall come back and we shall meet during the next session, wherein I will have a ready-made racetrack which I will have created by myself, either by myself or with the help of someone in Blender, and I'll upload it somewhere from where you can access it. So this is the end of the session. Goodbye, and I'll see you all next time.